Hello.
So, Assalamu alaikum.
Walaikum assalam. How are you all?
Yeah, fine, sir. How are you?
Okay, so what we have done in last class,
Sir, harmonic mean of individual speed.
Salman, any doubt related to last class?
No, sir.
Khalid?
Assalamu alaikum, sir.
Walaikum assalam. Any doubt related to last class?
No, sir.
Okay, so we had done average speed and we had derived three different relations how to calculate average speed if distance gap are equal, time gap are equal, and if they are different. Okay, so next part is velocity. As like we define speed related to distance, it means the rate at which distance covered by a body is called speed. Similarly, for the case of displacement, at what rate a body covers certain displacement is defined as velocity. So for velocity, we define it as the rate at which displacement is covered by a body, or simply call it rate of change of displacement is called velocity. Rate of change of displacement is called velocity. So on the basis of this particular definition, we can write velocity is equals to nothing but displacement over time taken. And displacement is shortest path between initial and final point. It is also the measurement of length. So we call its SI unit to be meter, and time is measured as second. So SI unit is meter per second. Since displacement has fixed direction, so we call it as a vector quantity. So the vector operated with some scalar, whether it is multiplied or divided, the resultant would be vector. So velocity is a vector quantity. There is another term, how to calculate average velocity. Average velocity, similarly as average speed, net displacement over total time taken is the ratio. So we define it as the ratio of net displacement covered by a body to the total time taken. So V average is net displacement over time taken. Any doubt to any of you? Salman?
No, sir.
No, sir.
Okay, just write it down.
Sir, by the way, from which chapter are we learning now?
We are learning third chapter, that is motion straight line, kinematics 1.
Oh, okay, sir. Thank you.
Okay.
Done, sir.
Okay. Khalid, done?
Yes, sir, done.
Okay. I'm giving you a question related to this. Suppose you have a straight path. This is your A, this is your B, and this is some point C. So from A to B is 240 meter, and B to C is 60 meter. If a body takes 10 seconds to go from A to B and 4 seconds to go from B to C, then find S average and V average for A to B, first part, and A to C, the second part. Try to solve these two parts. The movement of body goes like this. First A to B and then return to C. Hamza, any doubt while solving?
No, sir.
Okay. Hiba, doubt?
No, sir.
Khalid, have you solved?
Yes, sir. Almost done.
Okay. Salman? Iba, tell me your answer. Hamza, have you solved?
Yes, sir, almost.
Okay. Salman,
Yes, sir.
have you solved?
No, sir, do it.
Okay. Okay. Hamza, check your second answer. Khalid, send me your answer in chat box. Iba, should I solve? Okay, good. Next.
Sir, I have confusion in average speed
What is your confusion? Tell me about formula or what?
formula.
Average speed was nothing but total distance over total time. So for the first part, one going from A to B, the total distance traveled is
240 meter.
240 and total time taken on going from A to B is 10 seconds. So it will be 24 meter per second. Okay.
Okay, sir.
While calculating average velocity, since the path is a straight line, so distance and displacement would be equal. Okay, Eva?
Yes, sir.
So the displacement would also be 240 and time taken would be 10. So it would be 224 meter per second. For the next part, on going from A to C, Distance is the actual path covered by the body for the entire journey. So it will move like A to B and then come to C. So for average speed, total path length is AB plus BC. And total time taken is 10 plus 4. Okay.
Okay, sir.
So AB is 240 and BC is 60. So it will becomes 300. Divide by total time taken, 14 seconds. So it will be 150 divided by 7 or just divide it by 7. 7 twos are 14. 10717.740. 21.4 meter per second. Okay. Okay, Bam.
Yes, sir.
What about for average velocity? It is the net displacement for the journey. We have started from A and the final destination is C. So the net displacement between A and C. Okay.
Yes,
So
sir.
how to calculate AC? AB minus BC.
Yes, sir.
AB is 240 and BC is 60. But the time interval will be the total double for the entire journey. So it will be 10 plus 4. So it becomes 240 minus 60 is 180 and 10 plus 4 is 14. So it becomes 90 over 7, 71720, 7 to 14, 60, 7 8s are 7 7. Khalid, you have done something wrong.
Oh yeah, sir, in the second velocity, I got confused.
Velocity is the average velocity is the net displacement for the entire journey. So it will be just A to C. Okay, the shortest path between initial and final point. Okay,
Yes, sir.
Hamza, is it clear about? Is it clear?
Yes, sir.
Okay, so from this we can conclude that for a straight path, average velocity and average speed are equal. For any other path other than straight, average velocity is always greater than average velocity. So from this, we can conclude average speed is either greater than or equal to average velocity. Just like as we have done for distance and displacement, distance is always greater than or equal to displacement. Similarly, average speed is greater than or equal to average velocity. Hiba, any doubt?
No, sir.
Have you all written?
Yes, sir.
Khalid?
Yes, sir, done.
Okay. We have just finished uniform motion, that is motion without acceleration. Now we start uniformly accelerated motion. Means a body covers unequal distances in equal time gap for which the acceleration of body to be remains constant. So if a body covers unequal distances in equal time gap for which velocity linearly increases or linearly decreases. Velocity increases or decreases linearly with time. Then acceleration becomes constant. or having a fixed value. So we break this particular uniformly accelerated motion into two parts. First, for horizontal projection, and next for vertical projection. This vertical motion is based on acceleration due to gravity, or we simply call it as free fall or motion under gravity. So we will learn these two parts in two different manner. So second one is this term and third part is this term. Any doubt till now? Hamza?
No, sir.
Okay. Iba,
No, sir.
just write it down.
Sir, what did you write the second point?
Velocity increases or decreases linearly with time.
Oh, yeah, sir, after that.
Acceleration, a double c to the power n, the short form of acceleration. And it is constant. Have you all written?
Yes, sir.
Hiba?
Yes, sir.
So to solve these type of problem, we simply use in this particular whole part as equation of motion. If you have to calculate velocity, displacement, time, just use equation of motion in any of the two branches. So how to deal with that? I'm just explaining you. Just write it down. Done?
Yes, sir.
Okay. So next is equation of motion. You might have learned in class 9, there are three different equations of motion. First is V is equals to U plus A times T. Second is S is equals to UT plus half AT square. Third is B squared U squared 2 times AS. We have learned these three equations in class 9. There is another equation, S and F is equals to U plus A by 2, 2n minus 1. So what these equations actually mean? In any of the equation, acceleration is always constant. So first try to find acceleration to find any of the other quantities related to this particular equation. So first equation is velocity, acceleration, and time. Acceleration is constant. So it is called velocity time relation. In second part, Initial velocity in most of the cases would be zero. So we're left with just displacement and time. So it is called displacement time relation. Similarly, for third part, this is velocity and displacement. So it is called velocity displacement relation. And the last one is, this is S nth, displacement traveled by the body in nth second. This is simply displacement of body in nth second. So I'm giving some hint related to these four equations, how to apply these terms and what are they actually mean. Suppose you have a path like this, in which a body started from 0 seconds. So it may have interval 1 second, 2 second, 3 second, 4 second, 5, 6, and so on. 1, 2, 3, 4, 5, and 6. These three above equation is defined for period of journey. It defines from starting point to that particular final point. So these are called for period of time. It means from starting to end. Just as if I want to calculate displacement to 3 seconds, it will give you from 0 or from starting point to that particular point. So in this particular equation, just we are dealing with from starting point, that is 0, to that particular final terminal on which the journey had completed. So this is just the period for which we are dealing with. Next is, suppose if someone wants to calculate distance between any two consecutive seconds, like 0 to 1, so it is called first second, 1 to 2, this is called second second, 2 to 3, third second. And similarly for any two consecutive seconds, like 5 to 6, it will become sixth. This is nth, and this is just before that n minus 1. So this distance is called nth second distance. So the last equation, displacement of the body in nth second, defines you the distance traveled between two consecutive time gap. So it will define for point of time. So simply we can call it as displacement between two consecutive seconds or time gap. Any doubt related to these equations? Hiba,
No, sir.
Khalid?
No, sir.
Okay, good. Just write it down. Have you all written?
Yes, sir.
Yes, sir.
Yes, sir.
Salman, any doubt?
No, sir.
Okay. So how to solve any problem related to these? First, there is some assumptions. If a body starting from rest, so initial velocity of that particular body would be 0. If body finally stopped, then final velocity would be 0. Uniform motion means acceleration would be 0, and then final velocity and initial velocity would be equal. By knowing these assumptions, I'm giving you an example. Suppose body starting from rest, accelerate uniformly to cover 8 meters in 4 seconds. Find first part, acceleration of body. Second, velocity at 5 seconds. Third is displacement in third second. Displacement in 3 seconds after 2 seconds. Just try to solve. First, try to write what are the given term in the question. And on the basis of that given term, try to put equation related to that to solve the unknown part. Just as in this question, body was starting with from rest, so u would be 0. It covers 8 meters, means s is 8, and time is 4 seconds. So by knowing these terms, try to find first acceleration using second equation of motion. And try to solve rest of them further on its own. Salman, any doubt?
Until now, no, sir.
Okay. Any doubt while solving?
Yes, sir. Can you explain the fourth one?
Rest is done.
Yes,
Khalid,
sir.
send me your answer in chat box. Hiba, any doubt?
No, sir.
Hamza,
No, sir, no doubt.
Khalid, there is some mistake in your first answer. Please check it. Hiba, send me your first answer. Salman, send me your first answer. Value for acceleration. Salman, have you solved first part?
Yes, sir.
Tell me your answer. Hiba, have you done first one? Okay, good. U is equals to 0. Displacement is 8 meter and time is 4 seconds. So S is equals to UT plus half times 80 square. U is 0, so it will be 0. S is equals to 8 half. A we have to calculate and T is 4. The square of 4 is 16. So 2, 8 times 8 and it gets cancelled out. So A would be just 1 meter per second square. Okay, on the basis of this particular value, we have to calculate velocity at 5 seconds. So just use first equation of motion. V is equals to U plus A times T. We have U as 0, A acceleration to be 1, and time is 5 seconds. Just put all these values and try to find it. Okay, good. Third part is displacement is third second. Whether this particular time is point of time or period of time. Hamza?
Sorry, sir. I didn't hear you.
In third question, whether we have given third second, is it point of time or period of time? As initially I have defined you, if there is a time from starting to that particular end, it will call period of time. And if time is defined for 2 consecutive time gap, it is called just point of time. Just like between 2 and 3, it is called third second. Between 1 and 2, it is called second second. Is it similar to that?
Yes, sir.
So we call it as point of time. So we have to calculate displacement in third second, means distance in 2 consecutive seconds. So just use SNF is equals to U plus A over 2 times 2n minus 1. So we have U to be 0, acceleration to be 1, and n is the time, which is third second, so n would be 3. On putting all those values, just try to find S. Khalid, have you reached your answer?
Yes, sir.
First, second, third is done from all of you. Hiba,
Yes, sir.
Hamza,
Yes, sir.
okay. Salman, okay. So how to find fourth one? I'm giving you some hint. That question is asking to find displacement in 3 seconds after 2 seconds. What it actually means. Suppose there is a path like this, starting from 0, 1 second, 2 second, 3 second, 4 second, 5 second, and so on. So 3 second after 2 second, it means this is your starting point, and we have to calculate distance after it to 3 seconds. So it means distance from this point to this point. Okay, Khalid?
Yes, sir.
So now there is another problem, how to calculate these this particular distance, it is not same as distance between two consecutive seconds. That is defining for three different intervals. So to find this particular distance, we just say, let the distance from this point to this point is S1. Similarly, the distance from this point to this point would be S2. On calculating these two values, we can easily solve this particular part by simply subtracting these two terms. Okay, Hamza?
Yes, sir.
So for calculating this S1, the time would be 5 seconds. For calculating S2, the time would be 2 seconds. Since the above three equation was based on the period of time, it was defined from starting of the journey to that particular endpoint. So on the basis of that particular concept, just use to calculate from starting to that particular time, and by changing or by simply subtracting or adding to define between any two consecutive part or in two different intervals, you will be able to calculate. Okay. So for this, just use t is equals to 5 seconds. For this, just use t is equals to 2 seconds. And by knowing these two values, just subtract them to find s. So it would be nothing but s1 minus s2. Is it clear to you, Hiba?
Yes, sir.
Khalid, have you solved?
No, sir, not yet.
Okay. Hamza, have you solved?
No, sir, doing it.
Here it is displacement. So it's a SI unit would be in meter. Okay, Khalid?
Oh, okay, sir.
Salman, have you solved? Okay. Should I solve? By using second equation of motion, S is equals to ut plus half at square. Just put t is equals to 5 seconds for first part. So it will be S1. U was 0 plus half. Acceleration is 1 and time is 5 seconds. So it will be 25 over 2. That means 12.5 meter. Similarly, for S2, initial velocity is 0 plus half, acceleration is 1 and time here is square root of 2. So it will becomes 4 over 2 becomes 2. So we have to calculate S. S is nothing but S1 minus S2. S1 is 12.5 minus S2 is 2. So it will becomes 10.5 meter. Hiba, is it clear?
Yes, sir.
Hamza,
Yes, sir.
please check your answer when you have done wrong. Done.
Yes, sir.
Salman, done. I'm giving you one more problem. Just similar to your previous one. I'm giving you some hint related to this particular problem. In this question, here it is given, a body covers 9 meter in third second. It means just point of time. Similarly, 13 meter in fifth second. So it is just point of time. So we can use S and it is equals to U plus A over 2 times 2n minus 1. The first part, displacement is 9 meter. So it will be 9 is equals to U plus A over 2 and n is 3. 3 to the 6 minus 1. So it will be 5. So it will be our first equation. We have two different variables as U and n. Similarly, for second part, displacement is 13 meter, U plus A over 2, and time is 5th second. So n is equals to 5, 2 5 10, minus 1, 9. So we have second equation. So this is just linear equation two variable. Try to solve these two parts to obtain U and A. Any doubt? Khalid,
No, sir.
just send me the value of U and A in chat box after solving these two equations. Khalid, check your answer once again. I'm giving you some hint. Since U and U having same coefficient, so just try to eliminate U by subtracting these two equations. Simply subtract these two equations, U becomes cancelled. So we're left with only A. So from there, you can easily solve A. By knowing A, put the value of A in any of these two equations to find U. Hamza, have you done?
Doing it, sir.
Hiba? How to solve these two equations? There is first method. Suppose 13 is equals to u plus 9 over 2 times of a, and 9 is equals to u plus 5 over 2 times of a. Just subtract this. So it will be minus, minus, and minus. So u and u becomes cancelled out. 13 minus 9 before u minus u becomes 0. 9 over 2 minus 5 over 2. And a becomes common. So 9 minus 5 is 4, over 2 is 2. So it will becomes 4 is equals to a into 2 times. So on solving, a becomes 2 meter per second squared. Khalid, is it clear? Good. Hamza,
Yes, sir.
any doubt?
No,
So
sir.
now just try to put this particular value of a in any of these two equations to obtain u. Khalid,
Yes, sir.
have you solved again?
Yes, sir.
Did you get the same result?
Yes, sir.
Okay. Hiba,
Yes, sir.
have you solved?
Yes, sir.
Is it the same answer?
Yes.
Okay. Solve for u. Now I'm putting the value of a in first equation. It will be 13 is equals to u plus 9 over 2 times of a. A is 2. So 2 and 2 gets cancelled out. So we're left with 9 only. If 9 goes to the left hand side, it will become 13 minus 9, 4 meter per second. So by knowing these two values, u and a, just try to find this part. This is nothing but displacement in 4 seconds, that is S and F. Similarly, try to find this part as we have done in the previous problem. Hamza, have you done third part?
Yes, sir. Almost.
Khalid, Khalid, have you done third one? Hamza, check your answer once again.
Third one done.
Send me your answer. Hiba, have you done third one? Okay. For third part, we have to use Snth is equals to u plus a over 2 times 2n minus 1. As we have solved u, it is nothing but 4 meter per second. So we will put a is 2 over 2 and is so 2 4s are 8 minus 1 7. 2 over 2 gets cancelled out. So we're left with 4 plus 7. It will be 11 meters. Okay, Hiba?
Yes, sir.
Hamza?
Yes, sir.
Okay. Try to find fourth part as we have done in this particular problem. Khalid, have you done fourth one?
No, sir.
Are you stuck somewhere or you haven't tried?
Yes, sir, I'm stuck.
Okay. Suppose we have a path like this, starting from 0, 1, 2, 3, 4, 5, and 6. So we have to calculate distance in 3 seconds after 3 seconds. So it means first second, second, third, fourth, and fifth. We have to calculate distance after 3 seconds to this part. So how we solve this? Try to calculate from 0 to 6, first part. Let's call it as S1. So time in this particular would be 6 seconds. Similarly, try to solve from 0 to 3. Call it as S2 and time would be 3 seconds. On solving these two parts, just subtract them to find S. As simple as it is. Okay, Hamza?
Yes, sir. I have got the first part of it.
Okay. Just okay, let me solve. First, we have U was 4 meter per second and A was 2 meter per second squared. So first for S1, it would be U 4 into T plus half times A T squared 2 and 2 gets cancelled out. 4, 6, 24, and square root of 6, 36. So it will be 60 meter. Similarly for S2, 4 into 3 plus half times A and square root of 3. So it will becomes 4 into 3, 12. 2 and 2 gets cancelled out. Square root of 3, 9. 12 plus 9 is 21 meters. So S would be nothing but S1 minus S2. So 60 minus 21, it will be around 39 meters. Hamza has done wrong. Oh, Hamza has done correct. Khalid,
Yes, sir.
check your answer where you have done wrong. Hiba, any doubt?
No, sir.
Okay. So we have done these type of problem, or how to solve or how to apply these type of equation. There is some application related to this particular equation of motion. So let's continue. Have you all written? Should we move?
Yes, sir.
Okay. So next is application of these equation of motion. So the first problem is on the basis of reaction time. What it actually means. You might have learned in your biology, and I think 8th, 7th, or 9th class. Suppose if you touch any hot body, so you feel some heat over that particular receptor from which our nerve impulses are connected, which sends some message or information related to that particular change in our particular surrounding over there to our brain. Brain interprets it as heat or something causing harm over that particular skin. So it sends some message over that particular muscles to just put your hand back. So the first part is the action which causes something change is called stimulus. And the response the brain has taken over that particular part is called response or just reflexes. Is it clear?
Yes, sir.
So the total time duration during an stimulus and getting responded back is called reaction time. It may vary on the basis of that particular individual. It may have some 0.2 second, 0.1 second, 0.5 second, or any other time. So how it is related in this particular equation of motion? So I'm giving you another example. Suppose there is a car and a driver is driving that particular car with some velocity u. At this particular instant, he sees some object in front of it, let's say some individual in this particular path. So on just seeing, it just on just particular seeing, a stimulus gets injected and integrated to the brain. Brain recall it to the muscle of leg to just put brakes applied. During that particular interval, the driver or the whole particular car has moved some distance to this part. So the total time duration to get responded back for any of the stimulus is called reaction time. Time taken get responded against any stimulus is called reaction time. During this particular reaction time, the motion of this particular system would be remains uniform. So let's say distance traveled from this point to this point is called SR. In this particular path, acceleration of car would be 0. It will remain moved with the same initial velocity as it was moving. Okay. So using second equation of motion, S is equals to ut plus half at square a0. So it will be u times pr. PR is nothing but reaction time of that particular driver. Is it clear?
Yes, sir.
Khalid, any doubt related to this particular reaction time? Salman? Okay. Now,
No, sir.
due to that particular stimulus, brain has responded to muscle of legs to apply that particular things. So now brakes are applied. So this particular car gets decelerated or get retarded by some acceleration, let's say A. So it will stop after covering some amount of distance, let's say at this particular point. So at this particular point, car has become stopped. So final velocity of this car would be 0. Now, we have initial velocity, we have final velocity. So using third equation of motion, v squared is equals to u squared minus 2 times a s. As a is retarded, so we use negative sign. Final velocity of the car is 0. So from this, s would be equals to u square over 2 times of a. This particular distance is called stopping distance. We call it as st. From this point to this point. Is it clear?
Yes, sir.
So now the total distance covered by this particular car on just observing this particular individual and applying brakes until the whole process has done is this plus this. So it will be S is equals to SR plus ST. Now they would ask you a question whether the car will hit the individual or not. So by calculating this particular distance, try to compare the initial separation of car with that particular individual. Let the initial separation of car with the individual is d. If s is less than d, it means no collision. And if s is greater than or equal to d, it must collide. Okay, Khalid, is it clear? Hiba?
Yes, sir.
Okay, just check now.
Yes, sir. What is D there?
D is the actual separation between car and individual initially. Have you all written?
Yes, sir.
Khalid?
Yes, sir.
Iba? Done?
Yes, sir.
So in this question, their initial separation is 50 meter, that is D. We have acceleration, means retardation. We have reaction time, and we have initial velocity. So by knowing all these values, try to put in this equation to obtain S and compare S with D. Okay. First, convert this particular velocity into meter per second as it is given in kilometer per hour. Hamza, any doubt while solving?
No, sir.
Khalid, have you solved?
Sir, I am stuck.
Sir, I have done.
Expert. Hamza, your answer? Have you solved?
Yes, sir.
Send your answer. Khalid, just see. Here we have U is equals to 54 kilometer per hour just multiplied by 5 by 18. So it would be 18 threes are. So it becomes 15 meter per second. Initial separation of them is 50 meter and acceleration, which means retardation, is minus of 2 meter per second square and reaction time is 0.56. So we have two types of distances, total distances, distance during reaction time plus distance due to stopping part. Reaction time was U times ER plus stopping distances U square over 2 times of retardation. So I'm putting their values here. U is 15, reaction time is 0.5, U squared is 15 into 15 divided by 2 times A is 2. So 15 5s, 15 into 5 times, it will becomes 7.5. 15, 15, it will becomes 225 divided by 4. So total distance would be 7.5 plus 4 5s are 20, 2 5, 4 6 are 24.25 meter. So it will becomes 7 plus 56 is 63.75 meter. It is larger as compared to D. So it would definitely perfect. Yes, Hamza, you have done correct. Salman, Eba,
Yes, sir.
you have got the same answer.
Yes, sir.
Good. Khalid, Is it clear?
Yes, sir.
Just write it down. You have to simply put all the values related in the given problem as we have obtained in previous part. Khalid written?
Yes, sir.
Okay, good. There is one more application. On the basis of that particular stopping distance, suppose a car, or suppose to test the braking strength of that particular vehicle, test is performed by speeding up at different speed. Let's say this car is moving at some distance u and applied brake at this given instant. On applying that particular brake at this instant, it will get stopped to this particular part. So final velocity at this particular instant would be 0. Similarly, if this car would be moving at some different velocity, let's say u2, so it will get stopped at some different distance. Let's say at this point. So distance in first part would be, let's say S1, and distance in second part, it would be, let's say S2. In this part, we are just applying brakes to get stopped. So the vehicle will be retarded with some acceleration, let's say A. So here, retardation or deceleration would be A. Using third equation of motion, v square is equals to u square minus 2 times as, as v would be 0. So s would be u square over 2 times of a. Similarly for second part, this is the first part. Similarly for s2, it will becomes u2 squared over 2 times of a. As the retardation or the strength of brake in first segment and the second segment would be seen. So on just comparing these two parts, will be S1 over S2 is equals to U1 over U2 squared. By knowing this particular result, we would be able to find some of problems related to this particular retarding motion. Is it clear?
Yes, sir.
Just write it down. I'm giving you one example related to this. This is just test to check the strength of brake. Of vehicle. Khalid, is it clear to you?
Yes, sir.
Have you all written? Hiba, any doubt?
No, sir. Sir, done.
Khalid, written. Hamza, done.
Yes, sir. Done.
Salman, done. A car moving at 20 meter per second stops at 20 meter on applying brakes. So find stopping distance when it is moving at 60 meter per second. So we have U1 and U2 and S1. On putting all those values, try to find S2. Khalid, have you written the previous one?
Yes, sir. Sir, like, can you show the previous slide again? I just need to confirm.
Okay.
Oh, yeah, okay, sir. I written.
Okay. Hamza, have you solved?
No, sir. Sir, S1 is 60 meter.
No, no. U1 is 20 meter per second and U2 is 60 meter per second. We have S1 is 20 meter and we have to calculate S2.
Okay, sir.
Have you solved?
No, sir.
In difficulty? We have U1 is equals to 20 meter per second and U2 is equals to 60 meter per second. S1 is equals to 20 meter and we have to calculate S2. Yes, Khalid. Good.
Sir, do we have to find acceleration?
What is unknown in this particular part?
S2.
So we have to calculate S2 as we have derived a relation in this particular segment like this. So just put this all values related to this part and try to obtain S2. It was written in reading the question, you have to find stopping distance, not the acceleration or the retardation of the motion. Hamza, tell me your answer.
Sir,
Yes,
I'm
you.
doing almost finished.
Okay, okay. Hiba, have you done?
Sir, just the last part.
Okay. Salman, have you done? Send me your answer. Okay. Hamza, check your calculation. We have S1 over S2 is equals to U1 over U2 whole square. S1 is just 20. S2 we have to calculate. U1 is 20 and U2 is 60 and squared over it. So 21 times and 23 times. So it will be 1 over 3. The square of this particular part will be 20 over S2 is equals to 1 over 9. Now what will we do? Just cross multiplication. 9 would multiply with this part and S2 would be multiplied with this part. So it would be 2 into 9, it would be S2. So S2 would be 180 meters. Okay, Hamza?
Yes, sir.
Where we have done wrong?
Sir, in the cross multiplication part.
Okay. Hiba, is it clear?
Yes, sir.
Okay, we have just finished this whole topic as motion straight line or simply uniformly accelerated motion for the horizontal path. Just stop here. We will continue motion the gravity or just free fall in our next class. Okay? Okay, Salman? Khalid, any doubt? Okay then. Take care. Allah Hafiz.
Allah Hafiz,
Allah
sir.
Hafiz, sir.
No, sir, no doubt. Allah Hafiz.
Allah Hafiz.